Here I am dealing with composition of vapor phase of volatile liquid solution. Question 1. If the mole fractions of liquid components in a solution are chi A and chi B, then choose the correct expression for mole fractions of components in the vapor phase Ya and Yb. In the question they are asking to write correct expressions for mole fractions of components in the vapor phase. While dealing with the Raoult's law, we have seen a vessel containing two different liquids, A and B. The liquids are A and B. In the solution, mole fraction of A is chi A and mole fraction of B is chi B. Above the solution, there are vapors of both components A and B. Component A shows partial pressure of PA and component B shows partial pressure PB. PA plus PB gives you P total or total pressure, correct? Then in the vapor phase, the mole fractions of components. Component A, mole fraction is Ya. Component B, mole fraction is Yb. In the vapor phase, Ya is the mole fraction of component A, Yb is the mole fraction of component B. Ya may not be equal to chi A, Yb may not be equal to chi B. So what we can say is that mole fractions of components in the vapor phase may not be equal to mole fractions of the same component in the solution phase, correct? So then the question is, how can you express Ya and Yb? For expressing Ya and Yb, we depend on Dalton's law of partial pressures. Dalton's law of partial pressures, which we have studied in +1 classes in the chapter states of matter, correct? Then applying Dalton's law of partial pressures, Ya is equal to, that is mole fraction of component A in the vapor phase, Ya is equal to partial pressure of component A by total pressure P total. Same way, Yb, that is mole fraction of component B in the vapor phase, equal to partial pressure of B, Pb, by total pressure P total. Then coming to the options one by one. First option, Ya is equal to Pa by P total. Here also Pa by P total. So expression is correct. Yb, Pb by P total. Here also Pb by P total. Yes, it is correct. So expression given in option 1 is correct. Then checking option 2. When you go through the expression, it is clear that it is a modification of expression given in option 1. Instead of P total, it is written as Pa plus Pb. Here also, instead of P total, Pa plus Pb. So expression 2 is also correct. Then checking expression given in option 3. When you go through the expression, we find that Pa is expanded or written by applying Raoult's law. Pa is equal to P0A chi A. Denominator Pa plus Pb. It is also written as P0A chi A plus P0B chi B by applying Raoult's law. The same thing you can see in the case of Yb expression. Yb. Pb written as P0B chi B. Denominator expressed as P0A chi A plus P0B chi B. So expression 3 is also correct. So all the three expressions are correct. So option 4th one is correct. Okay. Question 2. methanol and ethanol form an ideal solution. The solution is prepared by mixing 32 gram of methanol and 23 gram of ethanol at 300 Kelvin. At 300 Kelvin, P0 methanol equal to 90 mm of mercury and P0 ethanol equal to 51 millimeter of mercury. Calculate mole fraction of ethanol in vapor phase. In the question they are asking to calculate mole fraction of ethanol in vapor phase. Here I am assuming A represents methanol, B representing ethanol. Methanol, all of you know, its molecular formula is CH3OH with the molar mass 32 gram. Ethanol, it is C2H5OH with the molar mass 46 gram. Here we have to calculate mole fraction of ethanol in the vapor phase. Mole fraction of ethanol in the vapor phase is YB. What is the YB equation? YB is equal to PB by P total. PB by P total. What is P total? PB by PA plus PB. So, for solving or for getting the value of YB, we need these two terms, P and PB. P and PB. In the question, see, solution is prepared. Solution is prepared by mixing 32 gram of methanol and 23 gram of ethanol. So they have given mass of methanol and mass of ethanol. So I can write here mass of methanol WA equal to 32 gram, correct? Mass of ethanol WB equal to 23 gram. Then you can convert the masses into number of moles by dividing with the corresponding molar mass. So here Na equal to mass 32 by molar mass 32 equal to 1 mole. Here Nb equal to mass 23 by molar mass 46 equal to 1 by 2 mole. 1 by 2 mole. Here it is 1 mole. Here it is 1 by 2 mole. So you can easily calculate Ka, mole fraction of methanol. Ka is equal to number of moles of methanol, that is 1, divided by total moles, 1 plus 1 by 2. 1 by 2. So Xa becomes equal to 2 by 3. Then you can calculate Chi b. What is Chi b? It is nothing but equal to 1 minus Chi a. 1 minus Chi a. Everybody knows. 1 minus 2 by 3. 1 minus 2 by 3 equal to 1 by 3. Okay. Okay. Then in the question you can see vapor pressures of methanol 90 mm, vapor pressure of ethanol 51 mm. So I can write here P0A equal to 90 mm, 90 millimeter of mercury. P0B, it is given as 51 mm of mercury. So next you can calculate PA by applying Raoult's law. PA equal to P0A Chi A. What is P0A? 90 mm. 90 into Chi A, 2 by 3. 2 by 3 equal to 60 mm. So partial pressure of methanol is 60 mm. Then partial pressure of ethanol PB equal to P0B Chi B, correct? Here P0B is 51 into chi b. Chi b means 1 by 3. 1 by 3. So PB becomes equal to 17 mm. So we have PA value 60 mm, PB value 17 mm. So you can easily calculate YB substituting PA and PB in the equation. PB is equal to 17, correct? PA is equal to 60 plus PB 17. On solving, we get 0.22. So answer is fourth option. Okay, answer is fourth option. Coming to question 3. Vapor pressure of pure liquids A and B are 450 mm and 700 mm of mercury respectively at 350 Kelvin. If total vapor pressure is 600 mm of mercury, find the composition in the vapor phase. So they are asking composition in the vapor phase. Composition in the vapor phase means mole fraction of A and B in the vapor phase. That is Ya and Yb. So they are asking to find out Ya and Yb. Ya is equal to partial pressure of A by total pressure. Total pressure. Yb equal to 1 minus Ya. Okay. P total, it is given in the question, 600 millimeters. So you can write here P total equal to 600 millimeter. Also they have given vapor pressure of component A 450, vapor pressure of component B 700. That is P0A given as 450 millimeter. Also P0B given as 700 millimeter, correct? Then we need P at A. P total given. Then we require one more type PA. What is PA? PA is equal to P0B, sorry, P0A into chi A. Chi A. This chi A you can calculate by using the equation P total equal to P0B plus chi B, sorry, chi A P0A minus P0B. Here P total is 600, P0B is 700 plus chi A which is to be found out. P0A it is 450 minus P0B 700. On solving we get chi A equal to 0.4. So you can calculate chi B using the equation 1 minus chi A is equal to 1 minus 0.4 equal to 0.6. So we have chi A value 0.4, chi B value 0.6. Then you can calculate PA. PA is equal to P0A. What is P0A? 450. 450 into chi A. Chi A it is 0.4. 0.4 equal to 180 millimeter mercury. So we got PA value. Substituting here PA 180 by P total. P total it is 600, correct? 600. Then we get zero point 0.3. So mole fraction of A component is 0.3. Then what is mole fraction of B component in the vapor phase? 1 minus 0.3. It comes out to be 0.7. So Ya equal to 0.3, Yb equal to 0.7. Answer is third option. Okay. Question 4. To avoid bends, the tank used by scuba divers are filled with air diluted with. Question is saying about bends. See, what is meant by bends? In the case of scuba divers, when they go deep in the water, there there will be high pressure. The increased pressure increases the solubility of gases in blood. Increases solubility of gases in blood. Solubility of gases in blood. When the divers come towards the surface, what happens is that pressure gradually decreases. As pressure decreases, what happens? The dissolved gases will be released. So it will release the dissolved gases. Dissolved gases. Then it will block capillaries and capillaries. The release of gases can block capillaries and leads to a medical condition which is called bend. See, to avoid bends as well as toxic effects of high concentration of nitrogen in the blood, scuba divers use tank filled with air diluted with the gas which is uh, helium. So option 3 is correct. Question 5. To avoid bends, tanks used by scuba divers are filled with diluted air. After dilution, the ratio of air is. See, when air is diluted, its composition becomes different. Then the diluted air contains 11.7% helium, 56.2% nitrogen, and 32.1% oxygen. So answer is 1. Okay. Thank you.